So yp will be this. So I have to operate this on this polynomial. So 1 is multiplied, which is x square minus 4x plus 1 plus 2 times d x square minus 4x plus 1 plus 3 times d square mean x square minus 4x plus 1. Let me simplify. X square minus 4x plus 1 plus 2. Now d, capital D mean d by dx. Differentiate this once, d by dx, which is 2x minus 4 plus 3. D square mean twice differentiate. Once this, second time 2. So let you simplify. This is x square minus 4x plus 1 plus 4x minus 8 plus 6. So 4x goes, this is x square, 6 or 7, minus 1. X square minus 1 is your yp. The general solution will be a plus bx ex and yp. This is yp, which is x square minus 1. This is your yp. This is your yp calculated. So this is the way you are calculating, applying, expanding using binomial, and you can have one term more, but that vanish because after taking the second derivative it is 2, and if you are applying the third derivative, 2 is constant, third derivative is 0. So you can have this. Let me have the something for you. Let me change the question. This is y double dash plus 4y, for example. Let me change the question. Polynomial is going to be the same. I won't bother about it. But I am telling you one thing, how to have this. Question is changed. This is y double dash plus 4y equal to 0. D operator form. D operator form. D square plus 4 operate on y equal to 0. The auxiliary equation r square plus 4 equal to 0. The roots are plus minus 2 iota. R is equal to plus minus 2 iota, here 0. These are the roots. So yc will be e alpha x, 0x, a cos beta x, 2x plus b sin 2x. This is your yc because I have changed second question, and with this is 4y because I am telling you one thing in it. Now the polynomial is d square plus 4. Polynomial is d square plus 4 and this is a polynomial function. Now you have to have this expanding using binomial series. But for the binomial, one term must be 1. So how to have 1? What you are going to do is the smallest degree. This is second degree, this is smallest. Smallest degree is taken out. This is 1 plus d square by 4. X square minus 4x plus 1. This you should, because for the binomial series you must have one term 1. And if you are going to 1, the smallest is taken out. So if you take it out, this is 1, this is d square by 4. So now this is 1 by 4 there. 1 plus d square by 4 raised to the power minus 1. X square minus 4x plus 1. Look at that. Now you are expanding this using binomial series and operate on. So 1 by 4 as it is, I am expanding 1 plus nd, n is minus 1. 1 minus d square by 4, this is x square minus 4x plus 1. And if you are noticing, d square is there. The next is d4. the square of this, so d4 by 16. So that won't work on this polynomial because polynomial is of degree 2. So what do I have is 1 by 4 there. I am operating this on this. 1 is multiplied. This is x square minus 4x plus 1 minus 1 by 4. Minus 1 by 4. Now d square mean twice differentiate. If you are differentiating twice, first is 2x minus 4, the other is 2. Second derivative 2. Let you simplify. 1 by 4 is there. This is x square minus 4x plus 1 minus half. And this is 1 by 4 x square minus 4x plus half. Because 1 minus half is half. So this is your yp and that is your yc. So the general solution is a cos 2x plus b sin 2x plus this plus x square by 4 minus x plus 1 by 8. I have multiplied 1 by 4 with the bracket. So this is your general solution for a second order linear non-homogeneous differential equation. But I will change the question little bit because third thing I am telling you one thing more. So third question is y dash. Third question. I have right hand side the same, but here y double dash plus 4y dash is equal to, for complementary function left hand side 0, d operator 4d, y dash mean d. Then the auxiliary equation is d is replaced by 4r equal to 0. The roots are 0 minus 4. R is taken out. This is r plus 4 equal to 0. This implies r equal to 0 and minus 4. Real distinct. So the solution yc will be 0x plus be minus 4x. This is yc. Now for yp, this is 4d. 4d. This is third question. 4d because this is polynomial. This is the polynomial I am taken 4d. Now this is a polynomial function. We have to expand this using binomial series and operate on it. But for binomial, one term should be 1. And I have mentioned in the previous question, smallest degree should be taken out. So here 4d is the smallest. 4d is taken out. You are left with 1 plus d by 4. 4d is divided by this, which is d by 4. And here x square minus 4x plus 1. Now 1 over 4d there, it is 1 plus d by 4 raised to the power minus 1, x square minus 4x plus 1. Expand, you have one, it expand using binomial series. So 1 over 4d as it is, 1 plus nd minus d by 4 and n minus 1 over 2 factorial, that goes, and this is d square by 16. I have stopped. X square minus 4x plus 1 plus n minus 1, minus 1 and minus 1 minus 1. 2 factorial goes and t square, that's okay. So 1 over 4d as it is, operating this on this function. First of all, 1 is multiplied, x square minus 4x plus 1. Minus 1 by 4 is taken out. Capital D mean differentiate once, which is 2x minus 4 plus 1 by 16 outside, twice differentiate, which is 2 and bracket close. 1 over 4d here, let you simplify, x square minus 4x plus 1 minus half x. and minus minus plus 1 plus 1 by 8 is this. Let you one more simplification. So this is x square minus 9 x by 2. You have this and this together. Or 1 and 2, 17 by 8. 1 plus 1, 2 plus 1 by 8. 17 by 8. Now, if you are thinking capital D is the differential operator d by dx, what is 1 over d? What is 1 over d? 1 over d is reciprocal of d. It means if capital D is differentiation, then 1 over d is integration. So what do I have is 1 by 4 there. I am integrating this term by term. The first is x cube by 3. The second is 9x square by 4. And the third is 17 by 8x. So that is your yp. Do not put any constant of integration here because we have two constant in the second order differential equation already in yc. So yc contains two constant. Do not put any constant. The general solution will be this plus that one. I hope it is clear. Case 2, when the right hand side of a second order differential equation is a polynomial function. Case never fails, but you have to be very careful while applying the binomial series. So how to have one term 1? One term should be 1 because this is the formula for binomial series. So the general solution, you can add them together. So you can write the general solution. Case 3. When f of x is equal to sine alpha x or cos alpha x, where alpha is constant. So make sure we are using D operator to solve second order linear non-homogeneous differential equation, and those are continuous function we are talking about. The polynomial are continuous. First case is exponential function is continuous, and then the trigonometric function sine and cosine. I'm not talking about secant, tangent, cotangent, no. Only I am focusing sine and cosine. So they are continuous function. Then two more cases, those are continuous. Make sure you should understand, because when I will teach you the Laplace transform, that is working on piecewise continuous function. So here the function are continuous. Differential equation on the right hand side are continuous functions. Make sure. So sine alpha x cos alpha x. This is a2 y double dash plus a1 y dash plus a naught y is sine alpha x. Suppose. Calculate yc as before. Left hand side equal to 0, the D operator, the auxiliary, and solve the quadratic equation, finding the roots. Looking at the nature of the root, write down yc. For yp, 1 over polynomial in D sine alpha x. So yp is 1 over polynomial in D sine alpha x, replacing D square by minus alpha square. Look at that, minus alpha square. you have to replace d square by minus alpha square, but second order differential equation contains d in it. You are not going to do anything with d. You have to have d square. D square by minus alpha square. You have to do this. D square by minus alpha square. If f of minus alpha square equal to 0, case fails. Case fails. Sometime it happens. Case fails, multiply by x and differentiate denominator. Now try to understand one thing. If this is d square plus d plus something, if you are differentiating denominator, it is something 2d plus 1 in the denominator, or 2d minus 1 or something, or d minus 4 something in the denominator. So how to apply the rule? Because this rule is working on d square. So if you are differentiating denominator, then rationalize and apply the rule. Once you rationalize the denominator, there is suppose denominator contains d plus 1. If you are rationalizing by multiplying and dividing by d minus 1, denominator becomes d square minus 1, and then since d square is appearing, you have to apply the rule. Example. Solve y double dash minus 5y dash plus 6y is 3 sine 2x. Let me have this. 3 sine 2x. It could be cos or sine. For yc, y double dash minus 5y dash plus 6y equal to 0. D operator form. D square minus 5d plus 6 operate on y equal to 0. Auxiliary equation. Replacing d by r plus 6 equal to 0, breaking up the middle term, r minus 3 equal to 0. So this implies r is equal to 2 and 3. So roots are real distinct. If roots are real distinct, solution yc will be ae2x plus be3x. This is yc. For yp, 1 over polynomial in d 3 sine 2x. Let me write down the polynomial, which is d square minus 5d plus 6. This is 3 sine 2x. So replacing d square by minus alpha square. This is the rule we are having. And alpha is 2. It means d square is replaced by minus 4. Minus 4 minus 5d plus 6, 3 sine 2x. So this becomes 3 sine 2x divided by 2 minus 5d. 2 minus 5d. Minus 4 plus 6, 2 minus 5d. Now at this stage you are going to have d square. For this you have to rationalize. Otherwise you cannot make it d. If you multiply, divide again, d is there. So you have to have rationalize, which is the best idea to rationalize. So yp will be 3 is there. So 2 plus 5d sine 3x, and here 2 minus 5d and 2 plus 5d. 3 is there. So 2 plus 5d sine 3x. Denominator becomes 4 minus 25d square. So since d square is again in the denominator, replacing d square by 2 sine 2x. Sorry, this is sine 2x. So this is 2 plus 5d sine 2x d and 4 minus 25 minus 4. D square is replaced by minus alpha square. Alpha is 2, square of that 4 and put a minus sign with it. So 25 4s are 100. 100, 104. 3 by 104. This is outside. Now operate this on this sine function. 2 is multiplied. This is 2 sine 2x plus 5. Capital D, mean derivative of this, which is 2 cos 2x. This is the derivative you are having. So you can simplify 3 by 104 outside, 2 sine 2x plus 10 cos 2x and bracket close. And we are having, this is yc, that is yp. General solution I am writing. The general solution will be yc plus yp. This is ae 2x plus be 3x plus 3 by 104 outside. This is 2 sine 2x plus 10 cos 2x. So this is the required solution. If a right hand side function is a trigonometric function, sine and cosine, how to proceed, and if d is there, you have to rationalize. Once you rationalize, as soon as d square is there, apply the rule and the numerator is operated on the function.